Alright, so in this video we're going to go over the concept of shaded area. So to start off really simple, I'm just going to find the area of each of these shapes. So the first one here we can see is a rectangle because our opposite sides are the same length. And we have 90-degree angles here, although I didn't draw them in, but this is a rectangle. So what we are going with is area of a rectangle, and that is our length times width. That would be our formula, so we're going to go 12 times 8, and 12 times 8 gives us 96, and the units we have is meters, so we end up with meters squared. Over here we've got the area of a square. So the area of a square, remember, is our side length squared, and so that is 5 squared, and that really means 5 times 5. And so you notice I really could have also kind of used length times width and said the length is 5 and the width is 5. So really squares could follow the same formula as the rectangles, and this gives me 25 meters squared. So I could find the area of two separate shapes really easily. What happens though if one of those shapes moves on to the other shape? And I'm now looking for what we call the shaded area. So the idea here is that we started with this rectangle, and if you think of this maybe as like a piece of paper, although ignore the units because that's a giant piece of paper. If this was a piece of paper and we took our scissors and we cut out a square from the middle so that this is an empty hole, how big is the area that's left over that is shaded or filled in? So really, this is kind of like what we just had on the last one here. I have a rectangle that's 12 by 8, and I can see that I still have my rectangle that's 12 by 8. And then I have the square, which was 5 by 5, and then I've got this square, which is 5 by 5. So I have the same shapes as I had on the previous page. So what I'm really looking at doing is I'm kind of taking my bigger shape, and I'm going to cut out the smaller shape's area. So I'm going to take my big shape's area and subtract the smaller shape. That's really all that's going on. When we've got a hole in this shaded area, we're going to take that area away from the total area. You have a piece of paper, you cut part of it away, you are subtracting some area. So if we think our big shape, that rectangle we had was 96 meters squared. The square was 25 meters squared. When we subtract 25 from 96, we get 71 meters squared. So that means that the part that was shaded in gray or colored in gray, this area here altogether is 71 meters squared. And that's how we find shaded area. So we essentially take the big shape, find its area, the small shape, find its area, and then subtract them. So let's look at this one. Find the shaded area. So I need to find this part that's colored in gray. So when I look, I'm going to have a big shape. So I got the big shape, and I'm going to be subtracting a small shape. Big shape minus small shape. When I'm looking here, my big shape, again, this big shape happens to be a rectangle. So let's start by finding the area of that rectangle. The area of the rectangle is going to be length times width. Now my width is easy to see. It's 10 centimeters. That's no problem. So the width is 10 centimeters. The length, that one's kind of weird. What's going on with the length? When I look down here, I can see that this portion, 10 centimeters. This extra portion here is 2, and this extra portion here is 2, so it's kind of like I go 2, and then 10, and then 2 more. 2 plus 10 is 12, plus 2 more, so my length is 14. 14 times 10 is 140 meters squared. All right, there's the area of the rectangle. That was the big shape. Now looking at the triangle, that's the small shape that's being cut away. So area of a triangle is base times height divided by 2. If I look at the triangle, the base, 10 centimeters. 10 centimeters. What am I doing here? You guys didn't stop me. Not meters squared. Centimeters squared. Get the right units, Mr. T. Okay, base 10 centimeters. The height. So the height has to go from the bottom, the base, up to the top of the triangle, and actually that ends up being the same thing as the width. So since the base to the top is the same as the width of the rectangle, my height is also 10. So it's going to be 10 times 10, but I need to cut it in half. Okay, so 10 times 10 is 100, divided by 2, that gives me 50 centimeters squared. So my big shape was the rectangle, that's 140. The smaller shape was the triangle, that one's 50. And when I subtract them in total, I am left with 90 centimeters squared. And that represents the shaded gray area. Find the area of the large shape, subtract the area of the small shape. Something like this looks kind of cool. I got a circle that looks like it's been cut out of a square, right? So, big shape minus small shape. Okay, so when I'm looking at these two shapes, the square is the big one. I can see that the square going all the way around the outside, all sides are the same. All sides must also be 8 centimeters. And that 8 centimeters also happens to be the diameter of the circle, because the circle goes all the way across the square. The area of the square is going to be the side length squared. The side length here is 8, so it's 8 squared, and that means 8 times 8, and that gives us 64 centimeters squared. Okay? When we are looking at the circle, so we have a diameter of 8, but we don't want the diameter. So remember, in a circle, if the diameter is 8, that means that I could take the radius and cut it in half. So if the diameter is 8, the radius is half as big. So the area of a circle, we are using pi r squared. R standing for the radius. Pi, remember, we approximate pi using 3.14. And then we're going to put in that 4 squared. Now, we have to do the 4 squared first because we have an exponent. And in our order of operations, it's brackets, exponents, divide, multiply, add, subtract. Exponents comes before our multiplying. So 4 squared is the same thing as 4 times 4, and that is 16. So it's 3.14 times 16, and when we multiply that out, we get 50.24 centimeters squared. So, big area was 64, small area 50.24, and in total, that gives us 13.76 centimeters squared for the gray area, which is this shaded part here going around the outside. That's the area that would be left over if we cut that circle out of the square. So really, shaded area, find the largest shape and find all of the holes. Find all those areas separately and subtract them.